Welcome back. I put a handy dandy little reminder there that says notes in the corner. So anything that I actually put in your note template, I'm going to put the little word notes there so you'll know that that's in your note template. You can always add more notes, and I may have you add things as we go along, but at least you know exactly what's in the note template from the presentation. So now we're going to be writing an equation in point-slope form. So another format for straight line equations is called the point-slope form, where x1, y1 is a point on the line. And the format for point slope would be y minus y1 equals m times x minus x1. You have the generic x and y that are always in your equation. That's what makes it a linear equation. We have x and y with no exponents or anything else done to them. And then you have the specific x and y from the point they gave you. So we want to, and then from slope and 1 or 2 points, we can write the equation in point slope form. If we don't have the slope, we're going to need 2 points. The 2 points to find the slope. We can use either point when we write the equation, however, in point slope form. We'll just plug the coordinates from one point into x1 and y1 respectively, and write the equation as y minus y1 equals m times x minus x1. We could also isolate y, and you should be able to either isolate y yourself or work with the equation if y is isolated. And we'll be doing that in this lesson here. So we're going to be writing equations from graphs, but this time in point slope form, as well as from when we're given a point in the slope, like this problem right here. And this one is in your notes. So we want to write the equation of the line with a slope of 1/2 through the point 2,5 in point slope form. All we have to do is replace m with 1/2 and replace the x1, y1 in the equation with the point, which was 2,5. So we have y minus 5 equals 1/2 x minus 2. And that's it. We're done. That's all there is to it. All right, so you have that one in your notes. Let's look at the next one. All right, so we want to write the equation of the line through 5, 6, and 7, 1 using point slope form. So now this time we have to find the slope. All right, so using the slope formula, we're going to take the difference in the y coordinates over the difference in the x coordinates and simplify if possible. All right, and it doesn't matter who's y1, x1, y1, and who's x2, y2. I decided everybody's going to be the first point, so we'll just make you the second point. All right, so we have 1 minus 6 divided by 7 minus 5. Right, and so we'll subtract here. We have negative 5 divided by 2. All right, that's our slope. We can use either point to write the equation of the line. So I'm actually going to write both equations. Right, and so this one's in your notes, and we have, if I use 5, 6, I've got y minus 6 equals negative 5/2 x minus 5. That's a funky looking parentheses. Or I could use the other point, and I'd have y minus 1 equals negative 5/2 x minus 7. And that's all there is to it. All right, let's look at the next problem. So this was a graph we saw before, right? If you remember, our slope here was a negative 4, right? That was our rise, and then our run was 2. So negative 4 divided by 2, or negative 2, is our slope. We can use any point at all. I could use this point here, 0, negative 1, the y-intercept. Can't use the x-intercept because I'm not exactly sure what it is. It might be a half, but can't tell unless I solve for it, which I don't need to do. I could use this point. I could use a negative 2, 0. I could use any point at all. This point here appears to be, this point here is negative 2, 3. We can use that point. Any point at all. That's what's great about point slope form. Oops, that's a negative. Well, I got the signs right, but I reversed the numbers. negative 2, 3. There we go. So I could use any of those points there. I think let's use a negative 2, 3. It took me long enough to write it. So let's use negative 2, 3. Right? And then if I use that point, I would have y minus 3 equals negative 2 times x minus a negative 2. And you should simplify out minus a negative. Don't leave it like that. Y minus 3 equals negative 2 times x plus 2. But I could have used any of the points here. If I used negative 2, 0, it would have been y minus 0 equals, slope was negative 2. Negative 2 x, and that would be minus a negative 2, right, which is going to simplify to a plus 2, right? And I don't really need the 0, do I? I could make it y equals negative 2 x plus 2. Right? So either of these equations is describing the exact same line. They're both correct. We could also rewrite this if we want to isolate y. We would just add 3 to both sides. And that would give us y equals negative 2 x plus 2 plus 3. And we can leave it just like that. You don't need to do more work unless you're asked to change that in a slope-intercept form. Otherwise, that is an acceptable equation for that line. Okay, let's look at the next problem. Right, this is the one I think it was in your notes earlier. I have another one in your notes, however, so you don't have to worry about putting this in your notes per se. All right, so here we want to find our slope. If you remember, let's see, what points did I use? I used this one and this one. Those are pretty good points. Actually, I think I used something else, but those points are very good points. We have a rise there of 2 and a run of 1. So this is our rise. This is our run. So this would be 2 over 1, or just 2. And now we can use any point at all. I could use that y-intercept. Right? So that y-intercept is 0, 3. I could use some other point. I could use this point right here. Right? That point there would be negative 2, negative 1. I could use that point. Right? Any point at all on our line. Maybe we'll use negative 2, negative 1. Actually, maybe we'll use both. So if I use 0, let's use negative 2, 1 first, and then we'll use 0, 3. So here, this would be y minus a negative 1. One of the reasons I chose this one equals, and our slope was 2, x minus a negative 2. And there's, once we simplify those double negatives, we have our equation in point-slope form. So y plus 1 equals 2 times x plus 2. Or if we want to isolate y, it's no longer in point-slope form, it's in like a modified point-slope form. If we want to isolate y, but just so you know how to do it, we would just subtract, I'll write that in there, subtract 1 from both sides. Right, and that would be y equals 2 times x plus 2 minus 1. If we chose that 0, 3, we'd have y minus 3 equals 2 times x minus 0. Right? We could simplify the 0 if we wanted. Actually, if we simplify the 0 and add 3 to both sides, we have it in slope-intercept form. Right? So I kind of like the one we've done. We'll just keep that one. Oh, I never wrote down what point we were using. So our any point we chose, or I chose, since I'm doing the choosing here, was negative 2, negative 1. Okay? So point slope is great because it doesn't matter whether or not you can identify the y-intercept. You can use any point at all. Here we have this one. Right? So, let's choose any point here. Let's just choose this one right here. Nice thing about these graphs is these points are really easy to find. Plus, I remember what the slope is, so down 1 to the right 3. Oh, that's not that, well, oh, what the heck, we'll keep it. I just realized I'm not in an integer here, but technically I could use it. All right, this one here is not a very pretty point at all because it's 4.5, because each one of these is a half, negative 1/2. So I'll just put negative 0.5. We'll keep it. We can use it. All right, so 4.5. This just goes to show you, you can use any point, even if it's a fraction, so long as you know what the fraction is. Here I do because I remember the slope. If you remember it too, it was down 1 to the right 3. Right, so negative 1/3 was our slope. How many times am I going to write it there? Negative 1/3 is our slope. And so we'll just use that 4.5, negative 0.5. This shows you can use any point at all. If you can identify it, you can use it. All right, so y minus a negative, let's put 0.5. Then it doesn't start to look like a 5. Equals negative 1/3 x minus 4.5. And then let's just simplify up that minus and negative. Y plus 0.5 equals negative 1/3 x minus 4.5. Right? And if we want to isolate y, you'll just add, actually subtract, excuse me, subtract, because it's positive, subtract. Now I'm missing a b. Subtract .5. I guess I don't need to write in this negative if I'm going to write subtract. 0.5. There we go. So that would be y equals negative 1/3 x minus 4.5 minus 0.5. All right, so we have point slope and kind of a modified point slope where y is isolated. When I was erasing, I lost my w there. One more problem, I think, one more, and this one is in your notes. All right, so here, the points to use are the most obvious points. They're the ones that are listed. All right, so on this problem, because it's not so easy to figure out points, we'd have to do a lot of estimating and maybe not be sure. Right? This one would be a lot easier. I'm kind of wondering, however, about that 0.518. That doesn't seem to be correct at all unless it's in the wrong spot. And it doesn't move because look where it's located. However, we'll just go with those points. And it looks like I've got 420 as a point, but not 518. Well, maybe these are just listed incorrectly or something. That looks more like 23. Let's just change that because that just doesn't match the graph at all. I, by the way, did not create the graph. I just appropriated the graph. So let's make that 523 now that I'm looking at it. That really doesn't match at all. All right, so any point, let's use 212. All right, so that means the x1 is going to be 2, and the y1 is going to be 12 in our equation. Our slope, we're going to use the slope formula. So that's 23 minus 12 divided by 5 minus 2. It's going to give us 13/3 as our slope. So that means m is 13/3. And now all we have to do is plug in. So we have y minus 12 equals 13/3 x minus 2. And then if we want to isolate y, we're going to add 12 to both sides. right, so that would be y equals 13 thirds. Come on. Just waiting for my writing to come up. And here it comes. X minus 2 plus 12. And there we go. So we have point slope, and then we have our modified point slope, where we've solved for y. I'll just put PS for point slope. All right, thanks for watching this video. There are a couple questions that follow. Bye for now.